Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over problems 21 to 25 of the Geometry January 2015 Regents examination. All right, let's take a look at problem 21. It reads, in the diagram below of triangle ABC, segment DE is parallel to segment AB. If CD is 4 units long, CA is 10, CE is x plus 2, and EB is 4x minus 7. What is the length of segment CE? So one thing you want to note about this problem is according to the splitter theorem, the sides parallel to the base divides the sides proportionally. Okay, so you notice DE is parallel to the base AB. Let's indicate that. So this side right here is parallel to that side. What happens is that it divides these two sides proportionally. All right. Now the steps we're going to use to find the length of CE, we're looking for this length right here. First of all, we're going to use the side splitter theorem, as you can see down here, to set up an equation that reflects the proportional division of these sides right here. Then we're going to substitute the values of the expression into the equation we have set up, and then solve for x. And lastly, we'll plug in the value of x into the expression for CE, and then we're going to know what the length of CE is, okay? All right, so let's go ahead and start off by setting up our equation. Now, in order to do that, let's use the side splitter theorem real quick. So the side splitter theorem on the right side here, let's say this is A, B, C, D. We have AB, so CD is equal to CD, which is CE, EB. All right, so let's go ahead and apply this theorem to this situation right here. So we have, so step 1, CD divided by DA. Okay, so this side CD corresponds to the A portion here, and then DA corresponds to the B portion here. That is equal to CE, which corresponds to the C portion here, over EB, which corresponds to the D portion of this side splitter theorem. Okay, so we have this set up right now using the side splitter theorem. So let's write that here using the side splitter theorem. Okay, all right. Now we're going to plug in the values of these side lengths into this equation, so we can have a solvable algebraic equation. Okay, so step 2 is to substitute. So we have CD. CD is 4 units long, divided by DA. DA is, well, let's write down what they are first. So CD is equal to 4. We're given that here. DA is what? Now, if you look at the 4 measures we're given, DA is not provided. So can we find what DA is? Well, if you take a look at this segment CA, the entire length CA is 10 units long. So from here all the way to there is 10 units. Okay. Now, if CD is 4 units, using the segment addition postulate, what is DA? DA is 10 minus 4, which is 6, right? So let me go ahead and show you the work. So DA is the entire length CA minus the length that we know, CD, using the segment addition postulate. CA is 10 minus the shorter side, CD, which is 4, so DA is 6. Nice. Now we have DA, we have CD. We also know that CE, the numerator on the fractional expression on the right, is x plus 2. And EB is what? 4x minus 7. All right. So let's plug in all these values into this equation that we have set up in number 1. If we do that, we're going to have CD, which is 4, over DA, which is 6, equals to CE, which is x plus 2, over EB, which is 4x minus 7. Okay, just by substitution, that's what will give us this expression right here. All right, now we can go ahead and solve this algebraically. Now to do this, we can simply cross multiply. So if we cross multiply, you just multiply the denominator on the left with the numerator on the right, and then the denominator on the right with the numerator on the left. Okay, so we're going to have 4 times the quantity 4x minus 7. Always use the parentheses so you don't make errors when distributing. 6 times the quantity x plus 2. All right, so distribute the 4 here. We'll have 16. X minus 28 is equal to 6x plus 12. Okay, now we're going to go ahead and solve this resulting algebraic equation. We'll try and get x by itself. Okay, so to accomplish that, we will subtract 6x from both sides. Subtract 6x. That gets rid of the x's on the right. And then we'll add 28 to both sides. Okay, so add 28, add 28. And add that downwards. That yields 10x. 16 minus 6 is 10. This adds up to 0. That adds up to 0 also. 12 plus 28 is 40. Divide both sides by 10. And then you get your answer. This implies that x is equal to 4. All right. So is our answer option number 4? The answer is no. We were asked to find the length of CE. We're not done yet. We just found what x is. All right. So don't fall into that trap. We have to finish the problem. So we know what CE is. CE is x plus 2. So let's write that down. CE is x plus 2. So by substitution, CE is simply 4 plus 2, which is 6. Our answer is option number 3. Okay, option number 3. All right, let's take a look at problem 22. It reads parallelogram ABCD with diagonals AC and BD intersecting at E is shown below. Which statement must be true? Now, there are a lot of properties of parallelograms that is good to know, but there are some that are applicable to this problem that you want to keep in mind. First of all, you want to know that for parallelograms, opposite sides are parallel and congruent. Okay? And then alternate interior angles of the diagonals are congruent also. And then diagonals bisect each other. All right? In this problem, the steps we're going to use are as follows. First of all, we're going to mark all the congruent components of the parallelogram. I'm going to show you these points that we were to note. I will show them to you in this parallelogram, okay? And then we are going to write down the statements resulting from our congruent components. And then we're going to compare with what we have here and see which of these statements is true. We're going to have a match. One of these statements is going to match one of the statements we have concerning this parallelogram. All right. So let's go ahead and get started. First of all, let's take a look at opposite sides. Opposite sides are congruent. Basically, AB is congruent to DC since they're opposite. What next? AD is congruent to BC. Okay, opposite sides are congruent. What else can we say? Alternate interior angles of diagonals are congruent. So let's see. So this is a transversal. Since this is a parallelogram, we know that opposite sides are parallel, right? So we have parallel lines cut by a transversal. This angle right here, DAC, is an alternate angle to BCA. They are both congruent. And angle um, CAB is an alternate interior angle with angle DCA. So this angle right here is congruent to this angle right here. Those are alternate interior angles. And then on diagonal BD, we have two alternate interior angles also. Angle BDC is congruent to angle CDA. So that angle is congruent to this angle right here. And angle A DB is congruent to angle CBA. So this angle right here is an alternate interior angle with this angle right here. They are congruent. Okay? Now, we also talked about diagonals. What about the diagonals? Diagonals bisect each other, right? So, what can we say here? If you take a look at diagonal AC, diagonal DB bisects it into two congruent halves. So this side right here is congruent, AE is congruent to CE. All right. And then the other diagonal, DB, E is a bisector. Segment AC bisects DB, and this segment right here, segment DE, is congruent to segment BE. Okay? So there you go. That's all the things that you need to know concerning this parallelogram. There are still more properties concerning like consecutive um, angles being supplementary and all that other cool stuff, but we don't really need that fact for this problem. Okay, so which statements must be true? Now, this is what we're going to do. We're going to look at the statement. If it's true, we'll state why. If it's false, we're going to state what the correct answer is. Okay? I'm going to test all of them because I want you to really understand this thoroughly, as opposed to just going to the correct answer. All right, so let's start with option number one. Option one we have, it says that BE, segment BE is congruent to segment CE. Now, is that true? BE congruent to CE, that's false. Okay, so what is the true statement? What's actually true concerning BE? We know that BE is congruent to DE because um, diagonal DB is bisected by AC. So the true statement is supposed to be that the true statement is that BE is congruent to DE. Okay? Diagonals of a bisector, of a parallelogram bisect each other. All right, let's take a look at, so option one is wrong. Let's take a look at option two. Is that a true statement? Option two says that angle BAE is congruent to angle DCE. So angle BAE, this green one with 2 marks, is congruent to angle DCE. This green one with 2 marks. Oh, they are congruent. That's true. Okay. Why is that true? Well, they are alternate interior angles. Alternate interior angles. Remember, alternate interior angles of a parallelogram along the diagonals are congruent. So our answer is option number 2. Okay, now I'm going to go ahead and do 3 and 4 so that you really understand what's going on here. Option 3 says that segment AB is congruent to segment BC. AB is congruent to BC. Is that true? No, that's false. What's the correct statement? AB is congruent to the side that's opposite it. What side is opposite AB? DC. So AB, the correct statement should be AB is congruent to CD. Okay? All right, now let's take a look at option number 4. Option 4, it says angle DAE is congruent to angle CBE. So angle DAE is the red one with just one arc, And then angle CBE is this blue one right here. Okay, so is this angle congruent to that angle? The answer is no, that's false. What is the correct statement? Angle DAE is congruent to what? If this is one angle, what is the alternate interior angle to this angle along this transversal here? The alternate interior angle is this one right here, angle BCA. Okay, so angle DAE is congruent to angle D, uh, angle BCA, right there. Okay, this is congruent to that BCA because these two are alternate interior angles. So statement numbers 3 and 4 are wrong. That's why we can clearly see that our answer is option number 2. All right, let's take a look at problem 23. It says in the diagram below of circle O, measure of angle ABC is 24 degrees. What is the measure of angle AOC? All right. So one thing you want to note in this problem is that if an inscribed angle, so in this problem here, this is the inscribed angle right here. Okay. So if, let's write that down, inscribed angle, that one has a measure of 24 degrees. If an inscribed angle has the same intercept the same angle, um, the same arc, sorry, intercepts the same arc as the central angle. So this is the arc under consideration right here, arc AC. Okay, try and draw it. So this is arc AC. So if an inscribed angle intercepts the same arc as the central angle, do you see the central angle? See this angle right here. This is the central angle. Okay, so let's mark that down, central angle. So if the inscribed angle intercepts the same arc as the central angle is twice the measure of the inscribed angle. Okay, so if these are x, guess what? This will be 2x. That's the relationship that you always want to remember. All right. Now, to solve this problem, what we're going to do is we're going to mark all the congruent components. Um, oh, no, sorry. Yeah, what we're going to do is we're going to set up an equation. We'll set up an equation using the central angle theorem. Okay, what I just talked about here is also illustrated in this yellow reference box. After setting up an equation, we're going to substitute the values of the angles we know and what we need into the equation and solve for the desired measure. Okay. All right. So let's go ahead and set up an equation. Basically, we know that if you have a situation like this, the if you double the inscribed angle, that gives you the central angle. Let's write it like this. The central angle is equal to 2 times the inscribed angle. All right, so here you got to be careful. Please do not interchange them. That's an easy mistake to make here. You interchange the central and inscribed angles. So our central angle is the bigger one, okay? The central angle in this problem is angle AOC. That is what we do not know, okay? We need to find the value of our central angle. All right, now what do we know? We know the measure of the inscribed angle. The inscribed angle, what is the inscribed angle? The inscribed angle is angle ABC, and that is equal to 24 degrees. All right. So now that we have our equation, we're going to plug this into, let me write down the equation first of all. So the equation is central angle, which is measure of angle AOC, is equal to twice the inscribed angle, measure of angle ABC. All right. And then we substitute, measure of angle AOC is what we do not know. Measure of angle ABC, we know that to be 24. All right, so this, if you work this out, this simply tells us that measure of angle AOC is 48 degrees. Answer is option number 3. All right, let's take a look at problem 24. It says triangle A prime, B prime, C prime is the image of triangle ABC after a dilation of 2. Which statement is true? So one thing you want to note is that under dilation, side measures are shrunk or stretched by a factor, okay? So the side lengths either get longer or shorter. If the dilation factor is greater than 1, then you have a stretch. If the dilation is between 0 and 1, then you have a shrink, okay? There's a shrinkage there. But another thing you want to note is that angular measures are preserved or unchanged. They remain unchanged. So it's only the side lengths that are stretched or dilated by the dilation factor. Okay, so please keep that in mind. Steps that we're going to use, we're going to sketch an example and label it fully just to give ourselves a visual of what the dilation situation is here. Then after that, we're going to write all the statements that are true under dilation and see which one matches the options that we have here. I'm doing this the long way just to help you see the full picture. I can use shortcuts, but that's not beneficial. I'm just going to show you all the statements that are true as a result of dilation, and then we're going to see which one is a match. Okay, so let's go ahead and sketch just a scenario that reflects the dilation of some random triangle by a factor of 2. All right, there you go. I chose a basic triangle, or basic 3, 4, 5 right triangle. Um, so this is our object. This is the original triangle ABC, and it's dilated by a factor of 2. So what do you notice? You notice that all the sides are double the sides of the original triangle here. All right. Okay, so if you have this situation right here, we're done with step 1. Step 2, what are some true statements we can make concerning this scenario? First of all, we know that segment A, side A prime, B prime of the image is going to be twice the corresponding side of the object. So twice AB, right? And then let's go to the other side. B prime C prime is going to be twice BC. And then what's the last combination? AC, A prime C prime is going to be twice AC. Okay, so you notice that all the side lengths of the original triangle have been doubled in order to get the side length of the image because the dilation factor is 2. All right, now how about the angles? Measure of angle A prime is equal to measure of angle A. Measure of angle B prime is equal to measure of angle B. And then measure of angle C prime is equal to measure of angle C. Okay, these two triangles are similar. Remember one of your similarity postulates, AA? Angles do not change under dilation. They are preserved. Okay, so the angular measures are the same. Now, let's take a look at what we have here. It says AB is equal to A prime B prime. That's wrong because AB is supposed to be, twice AB is equal to A prime B prime. So option 1 is wrong. Option 2, BC is equal to twice B prime C prime. So it's supposed to be 20 and it's supposed to be 10. That is wrong. BC is not 2B prime C prime. It's 2BC that is equal to B prime C prime. Okay, this is a dilation of 1/2. Option number 2 is wrong because 2BC is equal to B prime C prime. If you take a look at this equation that we have right here, this is the correct one. Okay, let's move to option 3. Measure of angle B is equal to measure of angle B prime. Absolutely right. Notice we have that right here because under dilation angles are preserved. So option 3 is the correct one. Let's just take a look at option 4. Measure of angle A is equal to half measure of angle A prime. That is totally wrong because angular measures are preserved under dilation. Measure of angle A is equal to measure of angle A prime. All right, so this is the only true statement, option number 3. All right, let's take a look at problem number 25. It says, in the diagram of the circle below, so we have the circle here, side AD is parallel to side BC. Segment AD is parallel to segment BC. Arc AB is equal to 5x plus 30, and arc CD is 9x minus 10. What is the measure of angle AB? Measure of arc AB. All right, so one thing you want to note in this problem is that parallel secants to a circle cut off or subtend congruent arcs. Okay, that fact is highlighted in our parallel secants equation here. Our B disappeared for some reason. Let me put it back. So you have two parallel arcs here, and you have two parallel secants. I meant to say two parallel secants, and you notice that they cut off two arcs. So they cut off this arc right here, and they cut off this arc right here. Guess what? Those two arcs that have been cut off are congruent. Okay, so just keep that in mind. If you have two parallel secants, cut two parallel secants in a going through a circle, they basically inter they subtend or cut off congruent arcs. So here, since AB is parallel to CD, measure of arc AC is equal to measure of arc BD. All right, so if this were x degrees, guess what? This will be x degrees also. All right, so that's something to note. So these are the steps we're going to use to solve this problem. We're going to identify the parallel secants and the subtended angles or arcs, okay? And then we are going to set up an equation, uh, substitute the value of the expressions into the equation, and solve for x. And then lastly, we don't want to forget, we will use the x value to find the measure of arc AB. All right, let's go ahead and do it. So I'm going to label this diagram right here. So what are our parallel secants? AD is parallel to BC. It was given to us, so these are our parallel secants. If these are the parallel secants, then these are the sides that, these are the arcs, the cutoff arcs or subtended arcs that are congruent. So this arc right here, arc AB, guess what, is equal to arc DC. All right. So we know we've identified our parallel arcs. I'm sorry, parallel secants. I keep switching it, and our congruent arcs. So we're now going to set up an equation. Okay. So equation is as follows. The let me see, what did I have here? Um, AB, arc AB is equal to arc DC. All right. Following the parallel, using our parallel secant equation. Now, so let's put the measure here. Measure of this is equal to measure of that. Okay. Now let's go ahead and set up an equation using the value. Well, we already set up an equation. Now we're going to substitute. So measure of arc AB is 5x plus 30, and then measure of arc DC is 9x minus 10, as illustrated in the circle. All right, so we're going to use this resulting equation to solve for x. All right, so to do that, I will subtract 5x from both sides, subtracting the smaller x from the bigger one, so we can have a positive x isolated on the right side. And I need the numbers on the left, so I have to move this 10 to the left by adding 10 to both sides. And then let's go ahead and combine the two equations. So we're going to have 30 plus 10 is 40. This adds up to 0. 9x minus 5x is 4x. This adds up to 0. Divide both sides by 4. And then we'll have x equals 10. Okay? So is our answer option number 2? We have 10 right here. Is that our answer? Of course not. That's not the answer. That is the value of x. We were asked to find the measure of arc AB. So don't forget step number 3, where we're to use x to find the measure of arc AB. So number 3, step 3 is not that long. Measure of arc AB is 5x plus 30. This was given to us. So how do we solve this? Just simply plug in the value of x, which is 10, right? So measure of arc AB is 5 times 10 plus 30. Using the order of operations, multiply first, 50 plus 30. Final answer is 80. Option number 4 is our correct answer. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found this tutorial helpful or beneficial to you, we'd like your positive feedback. So do give us a thumbs up. We'll appreciate it. Do not forget to subscribe to our channel so you can get instant updates to the remainder of this review series. If you have any questions or you like any support whatsoever for the Regents exam, the math section, of course, um, please um, place a comment in the comment section below, and we'll be glad to address your concern as soon as possible. More clips can be found on mathgotserved.com under test prep. Thanks again for watching and have a wonderful day.